Hello everyone, and welcome to this introduction module to the Houdini Academy Procedural Asset Production Masterclass. In this video, I want to focus on surface operators and how they relate to data flow. Specifically, how they create data, modify it, and output it at the end of a node chain. So I'm going to open up Houdini, and the first thing I need to do is create a geometry container. Because without a geometry container, we won't actually have the context in which we can place down our surface operators. Let's dive inside, and now we need to create some kind of geometry that we can work with. Let's press Tab, and here we can find all the nodes currently available to us in the SOP context. Now what I'm looking for is a node that will generate geometry. Under primitives, we can find them. For example, we can find our box or our sphere that we placed down before. But what I'm looking for right now is the grid. So let's click on the grid and place this down in our scene. Now the grid comes with a series of parameters that we can modify in order to change its base shape. And we can do this, of course, by typing into the fields, such as, say, I want to change it to a size 20 instead of 10, and this will scale up our grid. But we can also use the middle mouse button to middle mouse drag on these values, and we get this little interface element. If we scroll left or right while middle mouse clicking, we have the ability to change the values dynamically. If we move our mouse up and down while hovering over the UI element here, we can change the values faster based on the value that we select. So this is 0.1, this is 1, and up here we have 100. Let's set this grid back to 10. So I can type that in as a default 10, or let's undo that. I can also control middle mouse click on the parameter name. And by doing this, I will reset the parameter as well as any other parameter inside of its list. And this is important because this is actually a parameter with two values. We have the X value over here and the Y value over here. And this is how Houdini references the names of its parameters. If I hover over the size, you see the tooltip appears and it says size X and size Y. If I look further down, we see that the center value has three parameters called Tx, Ty, and Tz. This is because this is a vector parameter. So if I change these, I actually change the position of the object. Next we have this part here, which includes the rows and the columns for the grid. If I change this, we give it more rows or more columns respectively. Now these are integer values, and you can see that because they have these dots in between them. So this isn't a float, this is an integer. And up top here we have a couple of drop downs, and these allow us to change the type of connectivity, so basically how this mesh is generated. So instead we could switch it to triangles, for example, to give it a triangular pattern, as well as its orientation. And then we can also change it to a different type of mesh, such as a NURBS object. And when we change it to a NURBS object, we also enable some of the other parameters that were grayed out below over here, such as the U order for this NURBS object and the V order. Now I'm not going to explain exactly how NURBS work, that's not the point of this video, but what I do want to show you is that now we've changed this grid, and maybe we want to start changing some of these back. As I just demonstrated, we can control middle mouse click on any of these names in order to reset the parameter back to its default settings. We can also right click on any of these fields or the name, and then say revert to defaults, and this will do the same. If we want to change the entire node back to its original settings, we can go to the gear icon to the right of the node's name. And if we then scroll down and find revert to factory defaults and click on that, we will revert the entire grid back to what it was originally set to. So now that we know how we can manipulate parameters in the parameter menu and some of the different types of parameters, these aren't all of them, but it gives you a basic overview. Let's have a closer look at how we can start to take the information from this grid node and manipulate it. Because of course, generating a grid on its own doesn't do very much. Houdini's power, of course, lies in the fact that we can link nodes together to make different types of tools. So what I would like to do now is take this grid and add to it a modifier. And for that, I'd like to add a noise to this grid, so I give it a bit of a noise pattern in its height. We can do this by creating a mountain node. So press tab, and in order to find the mountain node, I'm simply going to type its name. And once I have enough letters typed, you can see it appear here at the top of the screen, it will start filtering out the mountain node. Once we have the one we want, we can either click it or press enter, and this will give us a mountain node to place down. Now, Houdini nodes have an output as well as an input. Some nodes in Houdini, specifically the grid nodes or the other generators, don't need an input, but others, like modifiers, do. So this node actually tells us it needs an input, and if I try to render this, it will actually generate an error if it doesn't have one. So let's click on the grid on the output dot and drag a line from it to the input of our mountain node. And doing this, we'll start to generate a noise pattern on our grid. So I can change the noise of this grid. Let's change the height a bit. And I can also change the scale. So I'm going to middle mouse drag and drag this up, and this will reduce the scale intensity a little bit. And this can be useful for example, generating a terrain or adding a bit of noise to a mesh. So next, let's add a color node to this grid so I can expand my network out a bit more. If I press tab and type color, I can find the color node in there, and the color node does very much what it says. It adds a color attribute, and by default it will provide a point color attribute to its input. If I click on the color swatch, I can then change what color I want to load. So let's give it a bit of a green color. So this looks a bit like a piece of terrain, right? And also let's grab our grid and scale this up a little bit. So I'm going to increase the amount of rows. I'm going to increase the amount of columns, so we get a bit of a higher resolution going on. Okay, so as you saw, I just changed my grid while I already had my mountain node and my color node applied. And this basically means that Houdini is sending data from our grid node up to the mountain node, which updates it with the height noise, and then we send it over to the color node, which updates it again with the color. And this highlights how data flows inside of Houdini nodes. In this case, SOP nodes have their dots at the top and the bottom, and the ones at the bottom are the output nodes, and the ones on top are the input nodes. This is different in the Vex context or the shader context, where the dots are left and right, but in general in Houdini data will flow from top to bottom, and in other contexts from left to right. So that's important to remember. And I quickly want to highlight how nodes in Houdini send that data from one to the other. When a node cooks in Houdini, meaning that it processes its data, it will store the information about what it finished cooking into memory for that node. When a node below it requests this information, such as say this color node over here, the data from this grid is loaded from memory, sent through its output node through the channels down below into the next node over. This node then processes that data and stores its changes to memory, and then from its output node feeds it over to the next node and the next node until we eventually reach the node that has the render flag. Houdini will only update nodes that need to be updated. So if I were to make a change to my mountain node here, for example, I won't actually update any data being read out from memory on this grid because it doesn't have to be updated. I can visualize that pretty easily by going to the performance monitor up at the top of the screen. And if I turn this on, it will start to record all the changes that Houdini is making and show me the performance hit that it gets and how long it takes to cook this information. Now this data is pretty light, but if I were to change my mountain node and say change the time value, changing its seed value, you can see how the mountain node updates and starts showing a red color. And this indicates the heaviest node in the network, the node that took the longest time to cook and make changes before it output to the end. Of course, again, this is very simple geometry, so this won't take any time. But if I were to update my grid and give it a lot of segments, like 200 segments each, I now have a much denser piece of geometry. And if I modify my mountain node, you can see that it might take a little bit more time to process. If you want to see the actual performance hit, you can go to the performance monitor and check out how long each node took, as long as it was recording to output data. I'm going to just stop this recording and click it again to reset my screen. If I go down back here, you can see that now the performance monitor view has disappeared. Now next, I would like to demonstrate how we can view this terrain in a different way. Right now we are looking at it through a smooth wire shaded view. And this means that we are looking at it with normal information displayed. So if I click on the normals of this terrain, you can see that they point in the orientation of the terrain, and that's why we see it in a smooth manner. But we still see the wireframe. So if I click up here and I click on smooth shaded instead, I will remove the wireframe from my view and view the terrain in a much more natural way. But if we don't actually have normals, or normals aren't properly set up, the terrain will look kind of weird. So instead we can use the flat shaded view instead. And this will show us the terrain in a more faceted style. So basically in its polygonal style. If we want to quickly toggle to the wireframe mode, we can also press the W key, and this will show us the terrain as a wireframe. I just quickly turned on the points for the terrain so it's better to see. If you want to change the color of your background, by the way, you can press D, then go to background and change the color scheme to say gray or dark. And this will allow us to see a bright piece of geometry much easier. Now for the purposes of this video, I'm going to change this back to the light style. So press D again, and we can set it back to light. Now press W to bring back my geometry. Now let's continue building out this little subnet that we've built here. I'm going to create a null node next. If I press tab and type null, I can bring up the null node. And the null node is effectively an empty node. It doesn't do anything except for pass data through it. It has some caching capability. We can cache our inputs, for example, if we want. But this is only cached in memory, very similar to any of these other nodes here. So it doesn't process data, it just stores it in memory. Next, what I would like to do is create a subnet out of these nodes, because let's say I want to turn this into a tool. I have my mountain node, which adds noise to my mesh, and then I have this color node, which colors that mesh. So let's press the subnet button here and wrap this into a subnet. And I will call this my mountain, or rather noise and color node. And what I've now basically done is wrap my nodes inside the subnetwork. Whatever I feed into the top is going to process through its contents inside and then come out the bottom to my null node. So let's have a look inside this subnet and check out what Houdini did. When we wrapped these nodes into a subnet, Houdini did a couple of things. First, it took the input that was coming from our grid and it plugged the input from the subnet into our mountain node. Next, it also provided us with an output node at the end of this node chain. And the output node is a dedicated node meant to make sure that whatever comes out of this subnet is always coming from this output node. It also allows us to create multiple outputs for the subnet. So if I make a copy of this, say copy paste, and I render this one, then we will see that it actually throws us an error. And this is because if I check the error message, we have two conflicting output indexes for this node. And this is because this node can only have one output node for one output point. If we look outside of this subnet, we can see that it has only one output dot. We can increase the amount of output dots that it generates, just like how it has more than one input dot, corresponding to its input numbers over here, by selecting one of the output nodes and setting its output index to a different number. In this case, I'm going to set it to 1. When we do this, and we were to click on the outside of the network again, you can now see that this node has 2 outputs. And if I change it up, we can also see that they both share the same data. And this makes sense because up here, both these nodes are being fed by the same color node. But what would happen if I were to plug the second output into just the mountain node and not the color node? Now this node bypasses the color node altogether. Now I go back to the top level again, and if I flip between these two inputs, you can see that we are bypassing the color node on this channel, indicating that the data is flowing from this to the mountain node and then to the second output node. And from this channel, it flows from the left channel here, the color node, and then the output node with value 0. And this shows us that data in Houdini can actually flow and be split into different channels, as long as the data always ends up at the render flag. Now that's not the complete story. We can actually render both sides at the same time, but Houdini will only update whatever it needs to update. Now if we want to split information in Houdini, we don't actually have to use an output node or a subnet. In fact, we can simply grab multiple nodes and drag it over here, and we can create more than one channel. However, only the render flag is what's currently being rendered. So if I only render one of these null nodes, only the data from this side is actually going to be processed. So in essence, what we've created here is a little processor. And this node takes the information from our grid, processes it through the nodes inside, and then outputs it. Let's say we want to create a different piece of geometry and process that instead. So I'm going to create a sphere object. Let's press tab and type sphere and replace our grid with it. Now by default, if I plug this in, you see that it doesn't actually work. And that's because our sphere is not a polygon type object. In fact, our mountain node doesn't know how to do anything with it and just bypasses straight through. It does color it, on the other hand, so the color node still knows how to work with it. Let's change our sphere to a polygon object instead of a standard primitive object, and this will allow it to be deformed. You'll also notice that the object is a bit too small for our node, so as long as we can't control the settings of our mountain node from the outside of this subnet, which is something we'll cover in the next videos, let's just increase the size of our sphere a bit and increase its resolution so we get a better result. There, that looks a bit better. So as you can see, we've basically replaced our grid with our sphere. But what do we want to combine them? Well, we can do this by using a merge node. And the merge node allows us to take two data streams and merge them together. So let's place a merge node down and plug both the grid and the sphere together into input 1. Now you can see that we have both our terrain and our sphere as if a giant meteorite had landed in the middle of it. Now maybe I want to do something else. Maybe instead I want to plug my sphere into my subnet. So I'm going to remove my merge node and plug this in. If I go inside, now the information from the sphere is coming out of our second input over here. And this time, instead of merging the data, I'm going to add a switch. And the switch node allows us to switch under a particular condition, usually a number value, which input it's actually using. So if I plug this into the same stream as our mountain and our input 1, and then I plug input 2 into the same switch, it will allow us to plug more than one input into this bar. Just like the merge node, it has a input point that is wider, indicating that it can take more than one input. Dots like this can send out more than one output, but the ones on top can only take one input. For the switch and the merge node, however, these inputs can take as many as you can provide. And you can reorder them through the menu inside of them. So we can click this and flip the inputs around until we like the order in which they're at. If we change the number on the switch, we actually change which input node it's currently using. And this allows us to flip between our inputs without having to make changes to how our network is connected. However, the input that's currently not active, so the dotted line, in this case the sphere, is not actually being updated whenever something changes up the network. Right now, for all intents and purposes, to Houdini, this switch has created a network connection very similar to just this, where only the grid is being considered and cooked. When we flip the switch to the other end, the same thing happens and it only processes input 2 instead. So this is a way to manage how data flows in Houdini and which nodes are going to be updated at any given time. If we put a switch at the bottom of our network, for example, and we switch it to an off state, then we might not actually need to cook any of the data above at all, as long as that data isn't being called by something else. And this allows us to bypass entire networks of nodes. So the last thing I'd like to discuss is how to prevent our networks from breaking. Because there are a couple of conditions that we could set up or do by accident that might break the links in our network. And well, let's have a look at how we can avoid these situations. The first one is if we don't actually use output nodes in a subnet. If we look inside of our subnet, we can see that we have our output nodes. And when we first created it through the Create Subnet button, it automatically gave us an output node for output 0. What if we remove the output nodes and try to just use the render flag instead? Well, let's create a copy of this subnet. So copy and paste. And let's leave the links intact. If I render the output of this network, it will automatically render output 0 in my viewport. Let's go in here and let's remove both these output nodes. And then let's go back out. Well, the first thing you notice is that since we don't have the second output node, we've lost the second output dot. But that was to be expected. But now let's have a look at what happens if we go inside the network and we render instead, say, just the mountain node and not the color node. If we go back outside of the network, you'll see that we've lost our color information, even though the color node is present inside the network. So it's important that you have output nodes inside your subnet. The second one, and let's get rid of this one, is that if you have a subnetwork and you want to extract its content out of the subnetwork, you can't really just do that by copy pasting. If I go inside the subnet and grab my switch, my mountain, and my color node and copy them, I could paste them outside this network, sure, but they wouldn't link up anymore. And this doubles as well for any references that these nodes might have to other nodes outside the subnet. And that has to do with how the address of these nodes is different from the address to these nodes. These nodes reside inside of the address of this one. If you recall, if you look at the tree view, these nodes actually reside under the address of the noise and color node. Simply copying them out would break any referencing they have, at least relative referencing. And we'll go more over this when we discuss channel referencing and custom parameters in one of the upcoming videos. But for now, let's just have a look at how we can properly extract the contents from a subnet without breaking everything. If you right-click on a subnet and you go to Actions, you can find under here Extract Contents. And when we click that, all the contents of the subnet will be safely ejected from the subnet. The subnet will be removed, so anything that was on the actual container will be gone, but the node network will still work and the links will still be established. And Houdini will automatically update any referencing that might exist from these nodes, so we don't have to worry about that either. And the last thing I just want to show is that the order in which nodes are provided data is very important. Node data cannot flow in a circle. You cannot have a recursive loop. If I just get rid of some of this here in the screen, let's say that I have my mountain node, I have my color node, and I have these creation nodes. But you see that the sphere actually has an input dot, and this one can be used to, by default, set the size of the sphere. Well, let's plug the color node into the sphere, and we see that suddenly the entire network breaks. If I switch my switch node to the first input, it will work again because at that point this link is ignored. But if we reestablish the link by switching it back to input 1, this breaks again. And if we look at some of these nodes and we check out the error message, we can see that there's an infinite recursion loop going on. Houdini cannot have a loop that never ends. It needs to have a start and it needs to have an end. And this expands even further when you start creating references, when you create expressions that drive your parameters, for example. So it's very important that we don't feed Houdini its own data, or it will start giving us error badges for every node that basically is forced to read its own data again. I can read any of the nodes in this loop and they will all error out because their precursor was receiving data that it actually got fed from itself. Let's not talk about recursion too much because it's going to do our head in. I'm going to break this link so we don't have an error anymore. Speaking of error messages, in the next video, I'm going to have a closer look at the topic of flags on Houdini, such as the render flag and the bypass flag we used earlier. But I'm also going to discuss badges, like the error message that we got earlier when we created an infinite recursion loop. And badges are useful to display information to us at a glance. So knowing what these mean and how to set them and what they do is important. So I hope to see you in the next video, and have a good one.